And using a refrigerant cycle of high and low pressure through expansion and compression, they're able to extract heat from the air, which is then used to heat our buildings. An air source heat pump then absorbs heat from the outside air into the refrigerant, even at low temperatures below freezing, and indeed special ones can work easily at -15. So all of these comments that our country's too cold or Scotland's too cold is rubbish. You know, the biggest provider or celebrator of heat pumps is Norway, where their winters are much more extreme than ours. So using electricity, the pump compresses the liquid, which increases its temperature to extract from the air, and then it condenses back in the house, back into a liquid, which then would release its heat into the building. So it's quite a simple policy. Then that heat is either sent to your radiators or underfloor heating, or it can be sent to the hot water cylinder. Next slide, please. So typically, for every electrical kilowatt of energy put into a heat pump, it can produce, typically in a heating mode, 3 to 4 kilowatts of heat. So let's think about that. You know, that's pretty magical, isn't it, really? 1 kilowatt in, 3 or 4 kilowatts to our space. Compare that back to our lovely gas boiler, where our particularly 80 to 98% efficiency. You can start understanding why people are talking about the carbon saving, the CO2 saving. So, clearly a heat pump is used in somewhere between 1/3 and 25% from a carbon point of view.